Okay, here we are looking at notes for 7-6 for algebra, example number 1. So Abby has a savings account. So right away, I'm noticing that a savings account, I'm putting my money into something. This is going to be dealing with a percent increase. If I was a loan, that would be different. Loans are assuming that you're paying interest. On a savings account, the bank is paying you interest. That's some knowledge that as ninth graders, the world, they assume that you know that. So our interest rate, that's important, 2.5%. She deposits $720 at the beginning of the year. So that's like my initial value. And again, all of this stuff I'm just picking out so far just from reading the problem. And this last little chunk about making no other deposits or withdrawals, you're going to see that a lot in these problems as making deposits or withdrawals complicates things, and that's not something you're going to really look into until you get to like algebra 2. So that will happen a lot. Okay, so let's think here. What percent will she have after 1 year? Well, we already decided that the percent was increasing. So what percent of her original amount is her original amount? And that 720 is not going to change. She's not getting rid of that. She's not losing that. If anything, that's growing. So that $720, that is the 100%. That's the whole total percent. That 100%, that initial amount is that 100% to start. Plus, well, they said it's increasing at an interest rate of 2.5%, would give us a total percentage of 102.5%. Again, why are we using the plus? Why are we using the increase? That's because in this problem, we're talking about percent growth or percent increase. If we're talking about decay or losing money or paying something money, we would be using the subtraction. Okay, so how much money will she have in 1 year? Could you go old school and use the percent over 100 kind of thing? Yes, but you don't want to do that anymore. You want to be using this brand new formula because this is going to make your life 1,000 times easier. So how much money will she have in 1 year? We're going to go back to that y equals initial value. My initial value was that 720 parentheses 1. I'm using the plus again because this was talking about increase or growth. So I'm using the plus sign instead of the minus sign. The percent that we're using is that 2.5%. So 2.5 out of 100, close the parentheses. And since here they're asking specifically for 1 year, I can just put 1 right there. Now, notice what happens when we kind of simplify this a little bit. I'm going to keep the 720 the same. But inside that parenthesis, that simplifies real nicely to 1.025. Coming from the 102.5%. If I were to take that, convert that back into a percentage, I'd have that 102.5%. Again, getting bigger than 1 inside there because this is growth. So at that point, I can go calculate that. 720 parentheses 1.025 caret to the first power. And that gives me with how much will she have after 1 year? The $738. And that makes sense because it's a little bit more. It's not a significant amount more because, those savings accounts aren't like you're not making bank off them unless you have a significant amount of money in them. But it is enough, a little bit. Makes it worth it. Okay, how much money in 2 years? In theory, you might be thinking here that you just want to add the $18 that it grew by and add that 18 once more, but that is not what you want to do. This is not linear. Remember, percents are not linear. They it's a different amount. Even though the percent is staying constant and we're still going to be growing by 2.5%, we no longer have $720 in our account. We have the 738 now, so that changes things. So how much money in 2 years? I'm going to use that same exact formula that I used for Part B, except I'm just going to upgrade the time. And that's why I'm upgrading the exponent. I'm upgrading the time, not the initial value, because that will just work itself out for me. So 2 years, I'm going to put it to the second. And I'm just going to copy that back down, change my 1 to a 2. And 756.45. 756.45 is the amount of money they'll have in 2 years. Still not needing to do anything with the rounding because I am rounding to the nearest hundredth if I have it, and both of those didn't require rounding. So, yay me. And as you can see, not the same amount as adding 18. If I took that 738 and added another 18 to it, like we might have originally thought, 756. Is it close? Yeah, of course it's going to be really close because 720 and 738 are close numbers. But it's not the same, and it matters when it adds up, especially as time goes by. So how much in 10 years? Same kind of thing. We're going to use that formula, y equals 720. And what's nice about this is a great example of what's nice about using this formula is that, instead of having to replace that new number, after 9 years and like keep going to figure all of that out, I can just change that exponent and it will do all of that calculating for me. To the 10th. And again, going back to my calculator, scrolling up because I can, changing that to 10, and boom, look at that. A little bit of rounding necessary here. 900, the zero, nope, so 921.66. 921.66. So, there we have it.